Okay, so next we're going to look at using the standardized tables in order to calculate normal distribution probabilities. Just like the binomial tables that we saw previously, there are pre-calculated published tables for us to look up probabilities associated with the number of standard deviations away from the mean. So these are all based on the fact that Z follows a normal distribution where the mean is 0 and the standard deviation is 1. This is what we call the standardized normal distribution. We'll look at how we can turn any distribution into this distribution later on. But for now, if we're working with the standardized normal distribution, how do we find our probabilities? So what is the probability that Z is less than 0? All right, so this is the mean plus no standard deviations. And we should now be comfortable with the fact that the probability is less than the mean is going to be 0.5. What about the probability that Z is less than the mean plus 1 standard deviation? We may be able to recall this from the 68, 95, 99.7 rule, or we can just use this handy table, and I'm going to look up this Z score of 1. So the Z score here of 1, I'm going to look up in the table, and that lets me know the probability that is less than or equal to 1 is 0.8413. So for any normal distribution, the probability that it's less than 1 standard deviation away is what we just found before, is 0.8413. And that's just a little bit more accurate than our 68, 95, 99.7 rule. Okay, what if it was less than 1.5 standard deviations? Once again, we'll look up this Z score, 1.5, in the tables, and we get 0.9332. So this is how we can make use of the tables to find our probabilities. It does go a little bit further than that. And here we're going to bring in back one of our properties of the normal distribution, which was symmetry. These tables are only going to tell me less than or equal to a particular Z score. What if I wanted to know greater than a particular Z score? So the probability that Z is greater than 1. On the diagram, I'm looking for this region shaded here. I can't look that up directly in the tables, but I can look up this blue region in the tables, and I'm going to end up doing 1 minus the blue region. The blue region is the probability that Z is less than 1. We saw that previously to be 0.8413, which leads to my final answer of 0.1587. Okay, so I can use the 1 minus technique that we used previously with the binomial distribution to help me find some probabilities. So that's actually the property that all of them add up to 1. So because we know the probabilities should add up to 1, I can make use of this 1 minus. Okay, what about this case? The probability that Z is less than negative 1.5. Well, on my diagram, this is the area that I'm looking for. I can't look this up on the table. As you notice, the table only reads from 0 and above, and I've got less than negative 1.5. Because the normal distribution is symmetrical, this probability and this area is exactly the same as being greater than positive 1.5. So this is where the symmetry of the normal distribution comes in. So to help me find the probability that Z is less than negative 1.5, I'm instead going to use the probability that Z is greater than positive 1.5. Okay, I'm still not quite ready for the tables because the tables will only tell me less than statements. So I know that this is the probability, this is the same as the probability that Z is less than 1.5. And once again, this can be looked up in the tables. All right, leaving us with an answer of 0.0668. Okay, so 2 ways that we used those previous properties of a normal distribution. We can use the symmetry, and we can use the fact that all of the probabilities should add up to 1, or the total area underneath the curve is 1, to then go ahead and solve a variety of different probability statements. The probability that Z exists in between these 2 values. So if this was my 1.54 and this is my 0.56, I'm trying to find the probability that it exists in between these 2 values. The standard technique to do this is, first I'm going to find this red area here. From there, I'm going to subtract this blue area, and that will leave me with the interval that I was looking to find. Okay, so that red area is the probability that Z is less than 1.54. And from there, we will subtract the probability that Z is less than 0.56. And that should lead us to our answer. So less than 1.54, we'll find that in the tables. And from that, I'm going to subtract the probability that is less than 0.56. Okay, and that leaves us with our answer of 0.2259. So this area here, the area that I've shaded black, is going to be 0.2259. We started with the larger value. We found out the area below that. We started with the second or the smaller value, and we found the area below that, and we subtracted the two of them from each other, which left us with the probability statement that answered the original question. Okay, so be careful with the way that you rearrange these statements and put them together. You're going to need some practice on this. You're going to need to draw diagrams for every question that you do. You're going to need to be careful. Are you doing a 1 minus? Are you doing a reflection? And are you finding the area or the probability in between two particular values? Okay, so moving on. So as I promised, we're going to look at how to standardize any normal distribution into the standardized normal distribution, so we can then go ahead and use the tables to answer probability questions based around that distribution. So firstly, let's look at two different distributions. So we'll take X follows a normal distribution of 32 with a standard deviation of 4. So the mean is 32 and the standard deviation is 4. And I want to try and find the probability that X is greater than 37. Okay, there are no tables designed for this particular distribution. There's only tables designed for everybody's favorite, the Z distribution. It follows a normal where the mean is 0 and the standard deviation is 1. So what we're actually going to try and do is we're trying to turn this X distribution into the Z distribution. Okay, so let's just quickly look at what each of these will look like if we were to sketch them. So this distribution, the mean is 32. The standard deviation is 4. So I'm actually expecting 36 to be around about here, 40 to be here, 28 and 24. Don't worry too much about getting those values exactly one standard deviation away. We're not really interrogating the accuracy of the diagram. Okay, but to emphasize that probability statement is really this area here. I'm looking for this area, I'm looking for this probability in my problem. All right, so once again, there are no tables for this distribution, so there's nothing to help me do this. What I'm going to think of instead is the standardization formula. So Z equals the X value minus the mean of the distribution, all divided by the standard deviation. So we're going to go ahead, say the probability we're transforming into the Z distribution, the standardized distribution, is greater. I'm going to use this formula to transform 37 into a Z score. So that's going to be 37 minus 32 all over the standard deviation of 4. That works out to be Z is greater than 1.25, 5 over 4, yep, greater than 1.25. What does this look like on the diagram? Well, for this distribution, the mean is 0, I have 1 standard deviation, 2 standard deviation, -1, -2 standard deviations, and I was looking for it to be 1.25. These areas are going to match each other perfectly. They match each other exactly, which is why standardizing is so useful. Now that we've standardized, I can find this blue area and it will match the answer to the black area. If I work out this probability here, I've worked out the probability in the original question. All right, so let's go ahead and do that. This is not table ready. Why is it not table ready? We're looking for greater than, and the tables are built for less than. So 1 minus the probability that Z is less than 1.25. All right, and now we are just ready to look that up in the tables. 1 minus 0.8944, which leads to a final answer of 0.1056. Okay, so this is how we're going to standardize from the normal distribution, any normal distribution, into one that we particularly want to work with. And then we can make use of the tables and work out from there. Okay, so let's add some context to that now. We'll go for this question. The measure of intelligence, IQ, of a group of students is assumed to be normally distributed with a mean of 100 and a standard deviation 15. Right, so the very first thing to do, let's just find the distribution. Normal distribution, the mean is 100, standard deviation 15. Don't forget to write it in the correct form with the squared. That's what we're looking for. Find the probability that a student selected at random has an IQ less than 91. So let's write that probability statement. So the probability that the student's IQ, the X is the random variable of the value of the student's IQ, X is less than 91. Okay, a couple of things just to check before we even go. 91 is smaller than the mean, and I'm finding less than 91. So I'm expecting this probability to be less than 0.5, definitely. That's going to be my first sense check as I go through this question. Okay, next we're gonna go on to standardize. So that equals the probability that Z is less than the standardized score. 91 minus 100 all over 15. It's the probability that Z is less than negative 9 over 15, so negative 0.6. Okay, trying to find the probability that Z is less than negative 0.6. Okay, let's take a quick diagram. Negative 0.6 is on this side. I want to know the probability is less than that. This is not table ready. I know that I'm going to need to reflect this. Positive 0.6. All right, so this is the same as probability Z is greater than negative 0.6. All right, still not table ready. I know I'm going to do a 1 minus on this. 1 minus the probability that Z is less than 0.6. So we're talking about this red area over here. 1 minus that area should give me my answer. And I can find that red area in my tables. All right, and the probability I'm looking for, 0.2743. Have a think, does it make sense? Yes, it's smaller than 50% like I anticipated to begin with. That's the value that I'm looking for. Okay, so now we're going to have a quick look at the alternate normal distribution tables, which you will be expected to make reference to at certain points, and we'll talk about what those situations are. Okay, these are often found accompanying the standard normal distribution tables. What these do, they offer up some Z scores for very specific situations. If you have a quick look here, it does tell us these are for when our probability is above the Z score that we're looking for. So as we read through the tables, firstly you'll notice that the probabilities are the first column and then the Z scores are second. Because here we should be looking up Z scores that match a probability that we're working with. Okay, so how do we read these tables? If I knew there was a certain value and 30% of things were above that value, I want to know what Z score has 30% above it. What Z score is exceeded by 30%? Looking in the tables, well, here's my 30% and here's the Z score that matches. This will be a Z score of 0.5244. And I can go ahead and use that in the question and in my problem solving as necessary. Similarly, what if I had a Z score that was exceeded by just 5% of the rest of the distribution? So this area here was just 5%. So once again, I'm going to look up that percentage in the tables. It's right here. That's 5%, 0.05. And the Z score to match, 1.6449. Okay, obviously bear in mind that for this particular Z score, there's 0.05 above it. Well, how much is below it then? Below this, we're going to have 95%. So our situation could have been phrased either way. What Z score has 95% below it, or what Z score has 5% above it. Either way, when we have a percentage and we're trying to look for a Z score, it's these alternate tables we might refer to. There are some very standard numbers here. So you're not going to find 12%, you're not going to find 7%, but just be aware of the percentages you will find. So 50, 40, 30, 20, and 10. Let's not forget 15%, so multiples of 10, including the 15. And then you have 5%, 2.5%, 1%, 0.5%, 0.1%, and 0.05%. Be extremely careful when you're reading these percentages, particularly the ones with the additional zeros. So I'm talking of the 50, the 5, the 0.5, and the 0.05. All right, so questions in whichever way they want may ask you to refer to these percentage points and to these alternate tables. Okay, so let's look for a situation where that might be the case. So if we had the distribution x follows a normal, 32 and 5, probability that x is greater than a equals 0.2. All right, what is the value of a? Well, I had a percentage here, and I want to work with finding this unknown real world value. Okay, starting with the percentage can be linked to a z-score, and that z-score can be matched up to a real world value through the standardization formula. So let's try and bring all of those bits in together. Okay, so we're concentrating on figuring out what is this z-score right here. Well, looking at the tables, I can see that that z-score that has 20% above it, it's going to be right here. So if I was to standardize, probability that z is greater than a minus 32 all over 5 will equal 0.2. Okay, so now I have a link. This expression for my standardized z-score should match the actual value 0.8416. If I put those equal to each other, I should then be able to rearrange and find out the value of a. Z-score should be 0.8416. And at this point, I know this is an expression for the z-score. This is the actual z-score. All right, just ready for the calculator now. And this is what I get for my value of a. A quick sense check. I am expecting something bigger than 32. So we're definitely there. I am expecting it to be less than one standard deviation above 32. So I'm expecting it to be less than 37. And it also fits that criteria. I'm happy that we've calculated the exact value of a. So this is how the alternate table should be used. If you know a percentage point that you're working with, you can find the z-score associated with that, and using the standardization formula, we can combine those to answer a whole new range of normal distribution problems. Okay, let's do one more type before we look at an exam question. Okay, so x follows a normal distribution of 100 where the variance is 16. The probability that x is less than b equals 0.4. What is the value of b? Okay, so a few things to notice here. I did mention the variance, and you are given the variance sometimes in the question, but we definitely want to write this in our standard form. All right, muscle memory is going to take the value that we see in the bracket and use it straight in the standardization formula. So we can do ourselves a favor by setting that up with the normal format, with the normal syntax. Okay, so looking at this situation, let's try and graph that. Probability that x is less than b equals 0.4. All right, I'm choosing a value where the probability that it's below is 0.4. That does mean it's going to be on this left-hand side. Probability of 0.4 is going to be on that left-hand side. The probability that it's below the mean is 0.5. So if that probability is getting smaller, I'm moving off towards the left with the value I'm thinking of. All right, that brings two things to mind. Firstly, if we know 0 is right here, my z-score is actually going to be negative. If it's on the left of 0, it's going to be a negative z-score. There are no negative z-scores in this table. What we're going to need to do is to think of the reflection. I know the z-score that has 40% above it. It's right here, 0.2533. So the z-score that has 40% below it is the negative version of that. It's negative 0.2533. So be really careful to get that correct. Once again, it's the diagram that's brought that out for us. Having that in front of me made me think instantly, I need a negative z-score and to set me up to respond to this question correctly. Okay, so let's go ahead and standardize. So the probability that z is less than b minus 100 over 4. Well, that equals 0.4. I know that this expression for the z-score and the actual z-score that I've got on the diagram should match up with each other. So I'm going to set that up. Negative 0.2533 should equal b minus 100 all over 4. All right, so some sensible rearranging is going to allow us to figure out the value of b. So b is going to equal 100 plus 4 lots of this negative 0.2533. And that leaves us with 98.9868. Okay, can we do a sense check? The mean was 100, and I knew this value would be very close to the mean since 40% is close to my 50%. So yeah, I'm happy that that's going to be an accurate answer, a sensible answer. 98.9868 is potentially the value of b. Okay, so once again, we use the diagram. We've used the alternate tables to find z-scores. We've used the standardization formula, and then we pull it all together with a little bit of algebra and rearranging to find b, which solved this problem. Okay, so the alternate table is very powerful in certain problems and how they've been posed. Let's get used to them. Okay, and we're just about finished, but before you move on to some practice questions, let's take a quick look at the specification and exactly what it is that students are expected to be able to show, exactly what the examiners are anticipating you will be confident on. While you read through that, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date, maybe come back in 2 or 3 weeks or before an assessment. And as you watch through the second time round, because you've done your practice, a lot of what you go through here should resonate with you much more. And you have a chance to really embed your understanding of the difficult concepts, the ones that have been flagged up as A star.